Hello everyone, welcome to Maths Tuition with Math. This is a brand new channel, so thank you to everyone who's watched the previous two videos. If you subscribe, please let me know by writing a hi in the comments so I can say hi back. Enjoy the video. So today's topics are going to be rounding, significant figures. We're going to use both of those topics for estimation and then later error intervals. Let's start off with rounding then. I've got the number 3,895. I'm going to round this number first to the nearest thousand. Start off by seeing which one of these numbers represents the thousands for place value, and it will be 3 for 3,000. The number behind it, we've got the 8 here. Now if this number is 5 or more, we round up, okay? Otherwise we leave it. So it is more than a 5. That's going to be 4,000 rounded to 1,000. Now we're going to round the same number to the nearest hundred. So the nearest hundred, for the digit that's in the hundredths, this is in the hundreds, so it's 800. Now the number behind it is a 9, so it will be rounded up. So this will be 3,900. Now for the nearest 10. Now this is the tens. There's a 5 behind the 9, that means the 9 will be rounded up to 10. Now 10 is a 2-digit number, so therefore it will be affecting the 8. So this will actually go into 3,900 also. Round 20.9 to the nearest whole number. Talk about the nearest whole number, we're talking about ones. So the ones would be here, it's the digit 0. We want this to be a full number, so the number behind the 0 is 0.9. 9 is more than 5. So this will be 21. We don't need to write the decimal because it wants it to a whole number. Round 8.219 to one decimal place. Now what that means is they want one number after the decimal point, which is here. So they want the 8 point something. So behind the 2 is a 1, that's less than 5. So it's going to be remained as 8.2. You have 1 minute to the question on the right hand side. Okay, significant figures. Round 84,407 to one significant figure. Now significant means important, and figure means the actual number, the actual digit. So let's look at this. I want one significant figure, so I want the most important number, just the one. The most important number here is 8. Okay, I'm going to round that. There's a 4 behind that, so it's not bigger than a 5. So the answer to that will be 80,000. Round 0.54 to one significant figure. The first important figure here is going to be 5. Okay, because it's 0.54. So 5 is our important figure, the first one, whereas 4 is the second important figure. But we're going to use 4 to round. So 4 is less than 5, so it will not go up. It's going to remain 0.5. Round 13,897 to two significant figures. So I want the first two most important digits here. The first two important digits is 1 and a 3. Okay, so after the 3, it's an 8, more than a 5. So that's going to go up to 14. I'm going to add the zeros to make it 1,000. 1, 2, 3. 14,000. round 1.3456 to 3 significant figures. So I want the first 3 significant figures. I've got 1, 2, 3. After the 4, it's a 5, so the 4 will be rounded up. It's going to be 1.35. You have 1 minute to questions on the right hand side. Estimation. Estimate 3.9 times 396. Now, keyword here being estimate. When it comes to estimate, you might like the word approximation. Okay, but estimation is used to do the calculation roughly. So we want numbers that we're comfortable with, easy numbers to times with or add with. Okay, so we want easy numbers to use. So therefore we're going to round the numbers to one significant figure. So I've got 3.9. I'm going to round that to 4. That's to one significant figure. Then I've got 396. I'm going to round that to one significant figure. That's going to give me 400. So 4 times 4 is 16. The 2 zeros, 1,600. Estimate 0.63 plus 5.3. 0.63 round to one significant figure is 0.6. Add 5.3 is going to be add 5. 0.6 add 5, 5.6. This question over here is a little bit more tricky. We're going to rewrite this whole question, read carefully, and then we're going to work it out using BIDMAS. So let's round first all of these numbers to one significant figure. 55 will be 60 to one significant figure. Add 899, we're going to round that to 900. All divided by 6.3, that will be 6 times 0.543, we're going to make that 0.5. Okay, let's do the top bit here first. 60 add 900, we're going to get 960. Divided by 6 times 0.5. Timesing by 0.5 is asking for half. Okay, so if you have any number that you times by 0.5, half the number. So 6 times 0.5 is 3. Now we're going to do 960 divided by 3. That's going to be 320. Estimate the total cost of 53 televisions at £197.60 each and 12 sound systems at £30.19 each. So what I'm going to do, I'm going to work out the televisions first, their total cost. So we've got 53 televisions. I'm going to use 50. I'm going to times that by 197.60. Let's use a better number, so one significant figure. It's going to be £200. And that gives me 5 times 2 is 10. Add the 1, 2, 3 zeros. That's £10,000 there. 12 sound systems, I'm going to use the 10 and £30.19. £30. So that's going to be 3 times 1 is 3. 2 zeros, 300. If I add the 10,300, that's going to be 10,300 altogether. That's the total cost of that. Remember guys, it says estimate, which means a good guess, okay? Do not sit there and work it out accurately because you will not get the marks. So estimate, round everything to one significant figure, and then do the working out. You have 2 minutes, do the questions on the right hand side. Error intervals. Some of you might know this as limits of accuracy. Now, this is the opposite of rounding. What you are given is the final number that's been rounded, and our job is to find out what the number could have been. Let's look at the first question. The mass of a letter is 64 grams to the nearest gram. Write the error interval for the mass of the letter. Now the letter is 64 grams to the nearest gram. If we think about this, what could have this number been? This number could have been 64.2. It also could have been 64.3. Or maybe 63.5. 63.6. Now if you think about it, we're going to have quite a few options. So what we need to do is we need to write an error interval. So a place where all the numbers can exist. So we're going to need the smallest number it could have been and the biggest number it could have been. Okay, but we're going to use crocodile mouths, the inequality signs, to help us with that. And the way we're going to do that is we're going to start off by writing mass, because we're talking about mass of the letter. Okay, and we're going to write the smallest number it could have been on this side and the biggest number it can stretch out to this side. So the smallest number this could have been is 63.5, and I want to include that 63.5 is smaller than or equal to mass. So that's the smallest number it could have been. Now we'll look at the biggest number it can be. Okay, the biggest number it can be is 64.49999. As you can imagine, the 9 is reoccurring. So what we're going to do, instead of having so many digits, we're just going to use 64.5. Okay, but our crocodile sign is just going to be less than. So basically it's going to be any number that's less than 64.5. The best way to remember this method is it always ends up with 5s at the end. Draw around the number y to one decimal place. Her result is 5.4. So it has been rounded to 5.4. Write down the error interval for y. So I'm going to start off by writing y in the middle. Put my inequality signs in. And as it's 5.4, that means there's a number that's missing that was here. So the biggest number is going to be 5 5.45. I'm going to fill this here. Whereas the smallest number it could have been 5.35. Okay, so 5.35 is less than or equal to y, whereas y is less than 5.45. You have 2 minutes to answer the questions on the right hand side. Well done guys for answering all of those questions. If you found this video to be useful, then please share with others and subscribe.